Okay. Hello, everyone. Good evening. Welcome back to our English class. I hope everyone is all ready to our session for this evening. I hope also that you have had your rest and enjoyed your Easter week. Um, we've had, a lot of days to rest and refresh for these days. So we are back again for another English session, for another English class, and we're going to continue with our last topic, which is all about oil and gas vocabulary. Now, for this session, we are going to talk about the last few words or terms about this topic, oil and gas vocabulary. So I hope everyone is ready and I hope you are all ready to listen all throughout the session. Before that, let's do a quick um, breathing exercise. Um, on my cue, inhale, exhale. Again, inhale, exhale. Okay, wait for a moment. I'm just gonna check if my audio and presentation is good. Okay. All good for the audio as well as the presentation. That's good. Now I have to check, of course, because we don't know what will happen if I don't check it. Okay. Again, we're going to continue with, for this evening, we're going to continue with our oil and gas vocabulary, which there are only um, one set remaining of terms. So this will be the last part for oil and gas vocabulary. After this, we are going to have an exercise to check if you've really understood our sessions, no past sessions about this topic. Okay. Now, again, let's do a review because it's been a long time. No, it's been a long time since we've had a discussion. Again, oil and gas vocabulary is our topic. Now, when we talk about oil and gas industry, it is a massive global sector that is responsible for finding and supplying the energy that makes modern life possible. So it is an industry built on advanced engineering, it is built on complex science, network of a worldwide network of facilities. So it is from providing the power for our homes to creating the fuel for transportation. So this industry is the foundation of our current energy system in all aspects of our life. And I've already mentioned it in the past few sessions that oil and gas are natural resources that take millions of years to form. They began as tiny organisms in prehistoric oceans that were eventually buried under layers of sediment. Over time, high temperatures and intense pressure transformed these remains into crude oil and natural gas. And because these resources are buried miles underground, discovering them requires sophisticated and advanced technology. So geologists as well as engineers, they explore the Earth's crust to find hidden reservoirs, and these deposits they are often found in some of the world's most remote environments, which include deep under the ocean floor or beneath the massive ice caps. And aside from that, we've already know what are the three main sectors, right? Because of course, getting the oil or the gas is such a complex process, very complicated process. So of course, that the industry traditionally divided the process into three main sectors or three distinct areas. Of course, each with its own specific focus. First is on upstream. Now, when we talk about upstream, it is more on the exploration, production. Basically, this is where the process begins. And um, There are a group of people. They are assigned to locate the potential oil and gas fields, and then upon locating, drills, they will also try to find drill wells to bring the raw resources to the surface. So it is a high stake environment involving massive drilling rigs. Okay. So again, upstream, that is exploration and production. Next, we have midstream. Midstream, when we talk about midstream, it is more on transportation, it is more on storage. So once extracted, the raw oil and gas must be moved. So this sector involves the use of giant ships like tankers. Aside from that, it also requires the use of extensive networks of pipelines that stretch across entire continents to safely transport energy. So that is midstream for transportation, for storage. And lastly, we have also the downstream. Now, in the downstream, we refine and we do marketing. So the final stage takes place at a refinery. Here, the crude oil or the raw ones, it is refined or cleaned and split into various products. This is also where the final products are sold to businesses and consumers. So that is, or those are the three main sectors: upstream, midstream, and downstream. Now, aside from that, a key part of understanding the industry is how we measure the massive amounts of energy. There is a measurement. For crude oil, remember that the standard unit of measurement is the barrel of oil, okay, or BBL. The standard size is that the one barrel, sorry, the one barrel is equal to 42 US gallons or 159 liters. Okay? But if you think about it, no, oil and gas is really, really essential because while we often think of oil and gas as just fuel for cars or for heating for buildings, their impact is much broader. The products refined from oil are used to create essential materials like plastics, fertilizers for agriculture, and even components for life saving medical equipment. So, this industry is really a vital service that powers our technology, that supports global trade, and enables the high standard of living that many enjoy today. Okay? All right, that's oil and gas vocabulary. Let's do also a review of the different words that we've had so far. First is the barrel of oil. I'm just gonna read the definition, okay? A standard unit of measurement for crude oil equal to 42 US gallons or 159 liters. Next, blowout preventer or BOP, a large specialized valve installed at the wellhead to seal, control, and monitor oil and gas wells to prevent and control the release or what we call the blowout. Basically, a critical safety device. Sorry. To continue, we have the casing head gas. Casing head gas is a natural gas produced from an oil well, dissolved in crude oil underground and released at the surface as pressure decreases. Next, catalytic cracking. It is a refining process that uses heat and catalysts to break down large, heavy hydrocarbon molecules into lighter, more valuable products. Directional drilling. This is the practice of drilling non vertical wells, intentionally deviating the wellbore along a planned path to reach targets not directly below the surface location. Drill bit. This is the cutting tool attached to the bottom of the drill string that breaks rock to create the wellbore. Drilling fluids. This is specifically formulated fluids, also called drilling mud. This is circulated through the drill string and then wellbore during drilling operations. We also have engine oil. a petroleum derived or synthetic lubricant used in internal combustion engines to reduce friction, cool components, and protect against wear. Fault trap, a geological formation where a fault or fracture displaces rock layers, creating a seal that traps oil and gas in a reservoir. Next is gas station, a retail facility where motor vehicles are refueled with gasoline, diesel, diesel or alternative fuels. It is also called a filling station, a petrol station or service station. Gusher, an uncontrolled release of crude oil or natural gas from a well after pressure is encountered causing oil to spray violently into the air. That is what we call the um, blowout. No, that's when pressure is encountered, which causes the oil to spray violently into the air. Next, so that is gusher. Next, injection well. A well you injection well, I'm sorry. A well used to inject fluids such as water, gas, or chemicals into an underground formation for enhanced oil recovery or waste disposal. So these are some words or terms so far that we've discussed already in the past few sessions. We're doing a review. Okay? Moving on to liquefied natural gas or the LNG. Natural gas cooled to negative 162 degrees Celsius or equivalent to negative 260 degrees Fahrenheit, converting it to a liquid state that occupies 1 over 600th of its gaseous volume for efficient transport and storage. Next, natural gas. A naturally occurring hydrocarbon gas mixture consisting primarily of methane or CH4, used as a major energy source for heating, electricity, and industrial processes. Oil field, a geographic area containing one or more oil producing wells, tapping into a proven underground petroleum reservoir. Oil rig, the complete set of equipment and structures used to drill a well, including the derrick, engines, mud system, and all associated machinery. Oil well, a boring or hole drilled into the earth to extract crude oil and petroleum gases from underground reservoirs. Petrol, a volatile, flammable liquid hydrocarbon fuel refined from crude oil, used primarily to power internal combustion engines called gasoline in North America. Pipeline, a system of pipes used to transport crude oil, natural gas, and refined products over long distances from production sites to refineries, storage, and distribution points. Next, platform. Platform, a large offshore structure from which wells are drilled, produced, and maintained. Serves as a base for drilling, production, and crew accommodation at sea. Next, plugging of well. Plugging of well is the process of permanently sealing a well that is no longer productive using cement plugs at various depths to prevent fluid migration and protect the environment. Next, we have the refinery. It is an industrial facility where crude oil is processed and refined into useful petroleum products such as gasoline, diesel, jet fuel, and petrochemicals. Next is roughneck. Okay. All right. So we ended actually a last session in platform. So there are how many words or terms left? One, two, three, four, five, and five. So there will be five more terms for this particular topic, oil and gas vocabulary. So those are the words so far that I've mentioned earlier that we've already discussed in the past few meetings. Again, this is part 4 for the topic. Let's start or let's continue with the plugging of well. Now, as mentioned here, it is defined as the process of permanently sealing a well that is no longer productive using cement plugs at various depths to prevent fluid migration and protect the environment. Now, the plugging of a well, it is the critical final stage in the life cycle of an oil or a gas well. It represents the process of permanently sealing a well that is no longer productive. This environmental and safety procedure ensures that the geological formation stopped during the well's lively productive years remain isolated from the surface and groundwater. So it is a way to preserve or to protect the environment. So, of course, we question why do these different wells must be plugged? Well, once a well in an oil field reaches the end of its economic life, it cannot simply be left open. Okay? Um, why do people behind this closes or plug the well? First of all, it is a legal requirement. Plugging is required by law when a well reaches its end of life to ensure that there are no long-term environmental um, dangers. So there should be long-term environmental protection, and that is why we close or we plug the well if it's not useful anymore. So that's a legal requirement. So it must be done. Next, we also have it prevents contamination. The primary goal is to really prevent groundwater contamination and surface leaks by blocking the migration of fluids between different rock layers. Third is environmental responsibility. So, in connection with the first one, there are an estimated 3.7 million abandoned wells in the US alone. Recent legislation like the 2021 Infrastructure Act allocated $4.7 billion specifically to address these orphaned wells or those wells that were not properly plugged, okay, or abandoned. No, those wells are abandoned. So that is or those are different reasons why we must plug well. It is first, it is a legal requirement, it prevents contamination, and we have a environmental responsibility to act or to do that. Now, how does a plugging work? So the plugging process is that when we try to plug a well, important, no, it is more of like a precision engineering that measure and mirrors the complexity of the original drilling performed by an oil rig or offshore platform. First, that we do is we clear the well. Any remaining production equipment and tubing are removed from the well bore. Next, we do is we set cement plugs. Multiple cement plugs are placed at critical intervals and varying depths throughout the well bore. Next is we do pressure testing. These plugs are tested to ensure that they are placed at critical intervals and varying depths um, and so that they can withstand the natural pressures of the formation, much like BOP, blowout pressure or preventer. So it manages pressure during active drilling. And then lastly, we also have we the final step is that we do surface cap. It involves cutting the casing below the surface and welding a steel cap over it. Basically, you try to close it, or it is often followed by restoring the soil to its natural state. So those are the different processes when we try to do plugging. We clear the well first, followed by setting the cement plugs. We do pressure testing, and lastly we close it. No, we do surface cap. Now, that's the final step. Now, of course, plugging a well is not cheap. Actually, anything about oil and gas, any kind of process that we do, when it comes to getting oil and gas, is not cheap, no? So when it comes to costs and logistics, it's really expensive because every well is unique. When we think about it, every well is unique. Some extending into fault trap, miles below the surface. So the cost of decommissioning can vary wildly. So that expense range, it costs typically range from $10,000 to over $1 million per well, depending on the depth and location. And of course, it's very complex in a way that a shallow land well is far cheaper to plug than a deep water well that required directional drilling or a multi-billion-dollar offshore structure. And resource management is the same type, like the same types of drilling fluids or the mud is used to maintain wellbore pressure during the start of a well's life, and they are often used during the plugging process to really maintain stability. Okay, so of course, what's the connection of plugging a well to energy chain? Well, plugging is the responsible bookend to the story of energy production. No, the journey that began with discovering a reservoir and producing a barrel of oil ends with a permanent seal. We always open and then close it. No, that's the full cycle. And then when it comes to waste disposal, sometimes old wells aren't just plugged, they are converted into injection wells to pump water or water or any kind of underground for carbon dioxide, a chemical underground for waste disposal or carbon storage. And then the vast pipeline network that once carried to a gas station or refinery are disconnected once the source well is successfully plugged. So that's on the infrastructure. So for everyone, the plugging of a well is a vital lesson in environmental stewardship because we are all environmental stewards. It shows that the vital service provided by the energy industry includes cleaning up and protecting the earth once our need for a specific well has passed. It ensures that the natural gas or petrol we used yesterday doesn't cause environmental problems tomorrow. Okay? That's the purpose of plugging a well. Next, we have refinery. Refinery, as defined here, it is an industrial facility where crude oil is processed and refined into useful petroleum products such as gasoline, diesel, jet fuel, and petrochemicals. Now, a refinery, it is an industrial facility where crude oil or the black gold extracted from the earth, it is processed and it is transformed into a variety of useful petroleum products. Far from being a single machine, a refinery is a sprawling city of pipes, towers, and tanks that operate 24/7 365 days to power global transportation and industry. So the core process of that is there's fractional distillation. At the heart of every refinery is the distillation column, which works much like a giant coffee maker. There is a heat-based separation. So crude oil is heated until it vaporizes. As the vapor rises through the column, it cools and then different components or fractions condense back into liquids at different temperatures. We also have layered products like light gases such as propane collect at the very top while heavy thick materials like asphalt settle at the bottom. And of course, the yield, a single refinery can produce 40 plus different products, ranging from aviation fuel to the petrochemicals used in plastics. We try to increase value through catalytic cracking. Distillation alone doesn't produce enough of the high demand fuels like petrol. So, to solve this, refineries use a secondary process called the catalytic cracking. What will happen if we do catalytic cracking? Of course, there's breaking of molecules. The process uses intense heat, 900 to 1000 degrees Fahrenheit, and a zeolite catalyst to really break large, heavy hydrocarbon molecules into smaller, more valuable ones. And then the output, this single technique produces approximately 50% of all gasoline in the United States. And a quick history fact, as mentioned here, and it is invented by Eugene. Where is it? It is invented by Eugene Howdry in 1830s, 1937. It was a vital service during World War II for producing high octane aviation fuel. Okay. Now, the global and infrastructure scale. Refineries are among the largest and most expensive structures built by humans. It is often located near a pipeline hub or a major port to receive resources from an oil field. The largest refinery is the Jamnagar refinery in India, that is currently the world's largest, capable of processing 1.24 million barrels per day, or BPD. That is the largest refinery. And then the measuring success is that the industry measures output by the barrel of oil, which is 42 US gallons, with a single barrel yielding about 19 gallons of gasoline after refining. Offshore support: while most refineries are on land, they process oil delivered from offshore platforms and oil rigs that tap into reservoirs like a full trap. And of course, we always remember the safety and operational support, managing the high pressures and temperatures required for refining is it requires a busy environment for constant monitoring. So there will always be pressure control, just as blowout preventer or BOP protects a well from a gusher. Refineries use complex valve systems to prevent accidents. Okay, that's a critical safety device also. And then maintenance. Specialized engine oil is used to keep the refinery's massive pumps and compressors running really smoothly. Byproducts is that refineries also produce as casing head gas and other natural gases, sometimes cooling them into negative 162 degrees Celsius to create liquefied natural gas for transport. Okay. Now, the end of the journey is to the here. Once refined, the finished products are distributed to the world. So that's the end of the journey. They do transportation. Pipelines really carry fuels to regional hubs, and then retail, gas lines, gasoline, and diesel family diesel finally arrive at your local gas station where they power vehicles protected by high quality lubricants. Environmental legacy: when a source well is eventually depleted, it undergoes the plugging of a well to ensure no fluid migrate and harm the environment. Okay? Again, this is refinery. Any questions so far? You can always use our chat box, everyone. Okay? I will be constantly checking, or I will be checking from time to time. Okay, again, that is a refinery. Next, we have a member of the roughneck. Roughneck, it is a member of the drilling crew who works on the drill floor, handling oil or drill pipe and operating equipment during drilling operations. So a roughneck, it is a skilled member of a drilling crew who performs the most physically demanding tasks on the drill floor of an oil rig or offshore platform. It is working at the heart of the busy environment that is modern drilling site. Roughnecks, they are responsible for handling heavy equipment, ensuring that the machinery keeps running during high stakes extraction operations. Their roles and responsibilities vary a lot. The life of a roughneck is defined by intense labor and the mastery of specialized drilling tools. First thing is they should be able to handle the drill string. No, roughnecks are primarily responsible for handling heavy drill pipes, tongs, and slips during the process of adding new sections to the drill string. And then there's shift work. They typically work 12-hour shifts in often harsh environmental conditions, maintaining 24/7 operation schedule. And then equipment maintenance beyond manual labor. They assist in operating and maintaining the rig's complex machinery, which includes the mud system used for circulating drilling fluids. Next, safety protocol. Because they work around high pressure equipment like the blowout preventer or BOP, adhering to strict safety standards is a matter of survival. Now, the professional environment here is that roughnecks work as part of a complete set of personnel and structures required to tap into a proven petroleum reservoir within an oil field. So, there should be drilling precision. They support advanced techniques like directional drilling, which allows the wellbore to reach a fault trap miles away from the surface location. There's also pressure control. Roughnecks are usually they help manage the density of drilling mud, which ranges from 8.5 to 20 plus pounds per gallon. So to maintain pressure and prevent dangerous gases, with the refining connection, the resources they have extracted eventually undergo catalytic cracking at a refinery to become the okay petrol sold at your local gas station. Okay. Now, of course, since we've mentioned roughneck is a very complicated and hard job, of course, there's a career and compensation for it. The term roughneck, it originated in the early 1900s to describe the calloused hands of the drill floor workers, but today it is considered a badge of honor in the industry. The entry level earnings, despite being an entry level position, the average salary for a roughneck ranges from $50,000 to $80,000 per year. So that's already a lot, right? Now, physical demand, it is widely regarded as one of the most physically taxing jobs in existence, as it requires significant strength and stamina. And then career growth, experienced roughnecks can move up to become drillers or tool pushers over seeing the entire engine's operations. Okay, so impact of this one roughneck on modern life is the work of a roughneck provides a vital service that powers global infrastructure. So we do energy harvesting. Every barrel of oil and cubic foot of natural gas harvested by these crews contributes to the 25% of enemy world energy demand supplied by hydrocarbons. Daily essentials from the engine oil that protects your car to the liquefied natural gas or LNG that heats homes. The roughneck's labor is at the beginning of the chain. Environmental closure when a well's life ends, these crews are often involved in the plugging of the well, ensuring it's permanently sealed with cement plugs. Okay? Oy, okay. So that is what we call a roughneck. So are we all good so far? It's already 6:34 p.m. We've done more than a half already. So let's do a quick break of 5 minutes so that you can rest well and you will be able to prepare for the next last terms. So time is 6:34 p.m. Please be back by 6:40. Okay? Okay, it's already 6:40 p.m. and we are back to continue with the remaining terms for oil and gas vocabulary. Okay, before that, let me do just, charge my laptop. I noticed that it's already low bat. It has low battery already for a moment. Okay, let's continue with another term. Next is roustabout. Roustabout. So far we've talked about plugging of well, refinery, and roughneck. Roustabout is more of, as defined here, it is more of an entry level laborer on an oil rig or in an oil field, responsible for general maintenance, cleaning, painting, and assisting the equipment operations. So still we're talking about the worker. Earlier we've talked about the worker called the roughneck, which is more on um, the complex process. So their job is really um, complicated. It's very um, dangerous in a way because they do handle drill pipe and operating equipment during drilling operations. Well, roustabout still a complicated and hard job. No, it is an entry level labor, though it is very hard. It's still very hard job. Okay, so here, roustabout it is an entry level labor who serves as the foundational workforce on an oil rig or within an oil field. It is, or they are often described as the boot camp of the oil industry. This role is essential for maintaining the busy environment and operational flow of both of onshore and offshore drilling sites. Their roles and responsibilities, they are responsible for a wide array of general maintenance and support tasks that keep the drilling site safe and efficient. When it comes to general maintenance, their daily duties include cleaning the equipment, they paint structures to prevent corrosion. They ensure that the deck or lee site is clear of debris. So those are general maintenance that they do. They also do loading and unloading. Roustabouts handle the heavy lifting. They manage the movement of supplies, equipment, materials from trucks or supply ships. They also do assisting operations. They provide critical support to more senior crew members. They assist with equipment operations and they help move heavy equipment or components like drill pipe. And then lastly, they do deck and site work. Offshore, they primarily work on a deck or of a platform. Onshore, they are stationed around the lease site. No, those are the different roles and responsibilities that they do. Now, the industrial ecosystem, roustabouts are the first link in a complex chain that leads to the production of a global energy resources. They do extraction support. So, by maintaining the rig's infrastructure, they support the primary mission of extracting crude oil from geological structures like a fault drop. They also do drilling assistance. They help maintain the systems used for drilling fluids or mud, which are vital for cooling the drill bit and maintaining well bore pressure. And of course, there's also safety vigilance. Their cleaning and maintenance work helps ensure that safety equipment, such as the blowout preventer or BOP, remains accessible and operational to prevent dangerous gushers. Now, career ladder and advancement for these people or for these workers, the roustabout position is widely recognized as the starting point for a lucrative career in the petroleum industry. Their career path is a successful roustabout can advance to become a roughneck, then a derrick hand, and eventually a driller. So, industry leadership, many high ranking executives and CEOs in the oil industry began their careers as roustabouts, which then they gain a ground level understanding of the vital service the industry provides. And it also serves as a training ground in a way that the role provides hands on experience with the entire production cycle from the initial drilling by an oil rig to the final plugging of the well. So, what's the connection to the consumer? While a roustabout's work is physically removed from the public, their labor eventually reaches every consumer. No, the refining journey, the crude oil they help extract is transported via pipeline to refineries. The final products through processes like catalytic cracking, that oil is turned into petrol or gasoline for your local gas station or engine oil for your vehicle. And then energy diversity, their work also supports the production of natural gas, which may be cooled into liquefied gas or LNG for the international transport. Okay, so that is the roustabout. And then we have the last term for oil and gas vocabulary, and that is the tension leg platform. As defined here, it is a floating offshore platform held in place by vertical tethers or tendons connected to the seafloor, designed for deep water oil and gas production. So, a tension leg platform or TLP, it is a specialized type of floating offshore structure that is used for the production of oil. It is also used for the production of gas in deep water environments. Unlike traditional floating platforms that move vertically with the waves, a TLP is designed for near zero vertical movement. No, it provides a stable base for drilling and as well as production operations even in turbulent seas. How it works. So, how does this particular tension leg platform works? No, especially when we're talking about the physics of tension. So, the defining feature of tension leg platform or TLP is its mooring system, which uses buoyancy to its advantage. So, they do vertical tethers. The platform is held in place by high strength vertical pipes or cables called tethers or tendons. There's also constant tension. The platform's hull is designed with more buoyancy than its weight. So this excess in buoyancy pulls upward, which keeps the tendons under constant high tension. And of course, they also make it sure that um, it is storm resilience. These tendons are engineered to be so strong that they never go slack, even during 100-year storms. They can actually stretch by several feet under extreme pressure without compromising the platform's stability. And then operational depth and environment. TLPs are highly effective in the busy environment or deep sea energy extraction. Water depths, they typically operate in water depths ranging from 1,000 over 5,000 feet. The historical milestone, the first TLP is the Houghton, which was installed in the North Sea in 1984, which which proves that the technology's viability in one of the world's harshest maritime environments is already there. And then when it comes to comparison, while a fixed platform is anchored by legs and limited to shallow water, a TLP or tension leg platform allows crews to tap into reservoirs like those found in the Gulf of Mexico or the Middle East. Life and work on board, so a TLP functions as a floating city and a complete set of industrial machinery. So when it comes to crew accommodations, similar to other large platforms, a TLP can house 100 to 200 workers. So that many. And then um Transport of oil and gas are sent via pipeline to refineries, so the crude oil or raw oil or gas. And then the refinement is that the crude oil undergoes catalytic cracking to produce petrol or gasoline and diesel. And of course, the end of life of it is once the reservoir is exhausted, the wells are sealed using cement plugs in a process known as the plugging of the well, which was mentioned earlier. This is to protect the marine environment. Now, why is tension leg platform a vital service in this industry? The TLP or tension leg platform represents a pinnacle of marine engineering. It provides a vital service by allowing us to access energy deep beneath the ocean floor that would otherwise be unreachable. So it really focuses on efficiency in a way that they often utilize injection wells. This is to pump water or gas back into the earth, which can recover 30 to 60% more oil. And of course, aside from efficiency, they also aim for stability because they don't move vertically. No, they allow for dry trees or wellheads located on the deck rather than the seafloor. They make maintenance much easier for the crew. Okay, so that is again the tension leg platform, and that will be the last term for oil and gas vocabulary. Any questions? Do you have any questions? So, for the whole thing, oil and gas vocabulary, we've already talked in the past few sessions 25 essential terms that you should know. Let's do a review of these terms. I'm gonna say the term and then define it. Okay? As simple as that. All 25 terms. First, barrel of oil, a standard unit of measurement for crude oil equal to 40 US gallons or 159 liters. Blowout preventer or BOP, a large specialized valve installed at the wellhead to seal, control, and monitor oil and gas wells to prevent uncontrolled release blowout or gush. Casing head gas, natural gas produced from an oil well, dissolved in crude oil, underground and released at the surface as pressure decreases. Next, catalytic cracking, a refining process that uses heat and catalysts to break down large, heavy hydrocarbon molecules into lighter, more valuable products. Next, directional drilling, the practice of drilling non vertical wells, intentionally deviating the well bore along a planned path to reach targets not directly below the surface location. Drill bit, the cutting tool attached to the bottom of the drill string that breaks rock to create the well bore. Drilling fluids, specially formulated fluids, also called drilling mud, circulated through the drill string and well bore during drilling operations. Engine oil, a petroleum derived or synthetic lubricant used in internal combustion engines to reduce friction, cool components, and protect against wear. Fault trap, a geological formation where a fault or fracture displaces rocks layers, creating a seal that traps oil and gas in a reservoir. Gas station, a retail facility where motor vehicles are refueled with gasoline, diesel, or alternative fuels, also called a filling station, petrol station, or service station. Gusher, an uncontrolled release of crude oil or natural gas from a well after pressure is encountered, causing oil to spray violently into the thin air. Injection well, a well used to inject fluids such as water, gas, or chemicals into an underground formation for enhanced oil recovery or waste disposal. Liquefied natural gas. Natural gas cooled to negative 162 degrees Celsius or negative 260 degrees Fahrenheit, converting it to a liquid state that occupies 1 of 600th of its gaseous volume for efficient transport and storage. Natural gas, a naturally occurring hydrocarbon gas mixture consisting primarily of methane or CH4, used as a major energy source for heating, electricity, and industrial processes. Oil field, a geographic area containing one or more oil producing wells tapping into a proven underground petroleum reservoir. Oil rig, the complete set of equipment and structures used to drill a well, including the derrick, including the engines, mud system, and all associated machinery. Oil well, a boring or hole drilled into the earth to extract crude oil and petroleum gases from underground reservoirs. Petrol, a volatile, flammable liquid hydrocarbon fuel refined from crude oil used primarily to power internal combustion engines called gasoline in North America. Pipeline, a system of pipes used to transport crude oil, natural gas, and refined products over long distances from production sites to refineries, storage, and distribution points. Platform, a large offshore structure from which wells are drilled, produced, and maintained, serves as a base for drilling, production, and crew accommodation at sea. Plugging of well, the process of permanently sealing a well that is no longer productive using cement plugs at various depths to prevent fluid migration and protect the environment. Refinery, an industrial facility where crude oil is processed and refined into useful petroleum products such as gasoline, diesel, jet fuel, and petrochemicals. Roughneck, a member of the drilling crew who works on the drill floor, handling drill pipe and operating equipment during drilling operations. Roustabout, an entry level laborer or on an oil rig or in an oil field, responsible for general maintenance, cleaning, painting, and assisting with equipment operations. And the last term is tension leg platform or TLP, a floating offshore platform held in place by vertical tethers, or what we also call as tendons, which is connected to the seafloor, designed for deep water oil and gas production. That is the tension leg platform. And those are the different terms for the oil and gas vocabulary. So that was a really long journey to learning the 25 essential terms of oil and gas vocabulary. There were four parts. I decided to do four parts because the terms are really complicated and I don't want to overwhelm you. Okay? So that concludes our deep dive into the essential terms and roles of the oil and gas industry. We've traveled from the initial discovery of a fault trap to the high stakes drilling managed by a roughneck on an oil rig or offshore platform. Through these profiles, we've seen how the industry operates as a complete set of advanced technology and human labor to provide a vital service to the world. Whether it is 2.6 millions um, of, of, um, of miles of pipeline or the complex chemistry of catalytic cracking that creates our petrol every stage is defined by precision and safety. Finally, the plugging of a well ensures that we protect the environment long after the production of a barrel of oil has has ceased. So we've discovered different phases. First is the discovery, the operations, the safety, the transport, and of course, the end of life. I hope all of the descriptions that I've provided throughout the different four sessions are clear and engaging for the foundation um, of your learning for this particular vocabulary. Any question before we end the session? I guess none. Thank you all so much for being with me all throughout the four sessions of oil and gas vocabulary. As mentioned earlier, I will be providing an exercise to assess your learning about our topic. Okay? That will be done tomorrow. That will be all for today. Goodbye, everyone, and have a nice night ahead. Good evening and good night. Goodbye.